Assalamualaikum. Pagi ni kita akan meneruskan ulang kaji kita dengan menjawab soalan trial set 2 yang ada dalam buku ulang kaji kita, buku Oring. Okey, kita mulakan terus dengan soalan 7. Cikgu pilih soalan ni kerana ia melibatkan soalan penyelesaian masalah. Jadi kita kena mahirkan lagi kemahiran kita dalam menyelesaikan masalah soalan yang menyelesaikan masalah ni. Okey, kita tengok soalan yang pertama 7 ni. So diagram 7 shows a transistor circuit, a switch controlled by lights. So transistor is to control is a relay transistor is a switch, right? Okay, first question, the next question. Next question, name the component J. So here is J. So J is LDR. Okay. On diagram 7, draw an appropriate component in boxscape. Okay, so for sure K is represented by a transistor. So what we need to know, what type of transistor, either NPN or PNP. So first we look at the terminal battery here. So this is positive. So this is positive. Positive, it will be NPN because N and positive must be reverse bias transistor. Okay, so this will be NPN transistor. Remember the arrow is downward. Okay. Right, next question. The transistor circuit in diagram 7 is incomplete cause the component in boxscape will damage. So state an extra component need to attach to the circuit and give reason. So this is a transistor. Remember, transistor cannot current the current that flow through the transistor must be small. It cannot be too big because it will heat up and damage the transistor. So we need to limit the base current here by using a fixed resistor. So we use a fixed resistor in order to limit the base current. So what is the position? So at the base terminal. Okay. Right. So move on to the next question. When the transistor circuit in diagram 7 is used as an automatic switch to light up a bulb 240 volt AC at night, it's found that the bulb does not light up. Okay, so what modification that we have to be done? So in this case, remember when the LDR is above, so remember the characteristic of the LDR, it will have a high resistance during night, out of dark, right? So in this case, when this is at night, so resistance here is high. So when resistance here is high, the voltage across the LDR also high. Automatically, the base voltage will be low. So when we low, less than base voltage, it will not base current will not flow, so it will not light up during night. So what we have to do is we interchange the position between J and R. So J at this at the base voltage and R here up here. So exchange or interchange the position of component J and component R. Reason, okay, to produce high base voltage at night. Yes. Okay. So again, when here is the LDR is here. During night, at night, when dark, the resistance will be high, so the base voltage will be high, and it will lights up the bulb. Okay. Right. Next question. The bulb 240 volt is used, so we want to use the AC bulb, but remember the output voltage is very small. It's about 6 volts, so we have to have what we call a relay switch. Okay, relay switch. Why relay switch? Because relay switch will activate the second switch, the second circuit which has the 240 volt AC bulb, which use a high voltage. So to switch on the 240 volt AC bulb in the secondary circuit. Okay. Okay, question 8. We go to radioactivity. Diagram 8 shows a system used in a factory to ensure the thickness of a cardboard sheet is uniform. Okay, so I think this diagram is familiar to you. Okay, the radioactive source, radiation detector. Okay, mana dia? Ni radioactive source, this is the detector, so they must be opposite to each other in order to detect the thickness of the cardboard. The radioactive source contain a radioisotope. The roller is used to compress the cardboard, so this is the roller. Alright, next question. So this is the table, give you all the radioisotope with their characteristic. So we have 3 characteristic: half-life, type of ray, physical state. First question, what is meant by radioisotope? Radioisotope is unstable isotope, isotope yang tidak stabil. Mudah kan ini, selalu kita dah biasa buat. Okey, soalan seterusnya, ini adalah soalan untuk kita membuat keputusan berdasarkan jadual yang diberikan dalam soalan tadi. Alright, first, so our task is we have to choose a radioisotope that can be used to detect the thickness of the cardboard sheet. Okay. First, half-life. Of course, we have to use long half-life. Long half-life partnership is what? Long, lasting, save cost, tahan lama, jimat cost. Type of radiation, we have a choice, is a beta or gamma. Normally we use beta because beta have medium penetration power. Right, next, physical state. So we will choose solid state or perpejar, easy to handle or mudah diuruskan. So based from this table, so we use strontium. Okay, next, the radioisotope is used to detect the thickness of the cardboard sheet. State the change the reading of the counter when the thicker cardboard is used. When thicker cardboard, so not many radiation can pass through the cardboard, so the reading will become lower or decrease. How the thickness of the cardboard sheet reduced? So we use the roller to compress more on the sheet. Right? Now calculation. Remember half-life calculation. The half-life of cardboard 60 is 5.27 years. Calculate the time taken for the activity of cardboard 16 to reduce to 12.5% of its initial value. Right, so percent, so if percent we start with 100%. Okay, 100%, 50%, 25%, 12.5%. So we have how many half-life? 1, 2, 3. So we have 3 half-life equivalent to 3 times 5.27. So given here is half-life, 1 half-life is 5.27 years. So 3 times 5.27 equals to 15.81 years for year, or tahun, sorry. Okay, sekarang kita akan masuk ke section B untuk jawab soalan esei. So kita mulakan dengan soalan 9, question 9. Diagram 9.1 shows a duck mother and her duckling floating in the water river. So this is a mother, this is the duckling, anak itik. Alright, their wave are balanced by the buoyant force. Berat mereka diseimbangkan oleh daya apungan. So remember where is the arrow of the force? So buoyant force outward and downward force is the wave of the duck. Right? So first question, what is the meaning of buoyant force? So buoyant force in an upward force due to wave of water displaced. Or daya ke atas disebabkan berat air disesarkan. Okay, sebab bila masuk dalam air ataupun dalam udara, ia akan mengalami daya apungan ataupun buoyant force. Okay, question B1. Using diagram 9.1, compare the wave of the duck mother and her duckling, the volume of the water displaced and the buoyant force acted on both of them. State the relationship between the buoyant force and the volume of water displaced to make a deduction on the relationship between the buoyant force and the wave of water displaced. Okay, soalan ni mudah kan? 5 markah confirm boleh dapat. So kita tengok markah yang pertama. So wave duck mother like greater than duck. Berat ibu itik lebih besar daripada anak itik. Okay, yang kedua, volume of water displaced of duck mother bigger than duck. Isi padu air sesarkan ibu itik lebih besar daripada anak itik. Yang ketiga, buoyant force duck mother larger than duck. Daya apungan ibu itik lebih besar daripada anak itik. So now we move on for the relationship. Okay, nak tengok yang keempat ya, higher volume of water displaced, higher buoyant force, or you can say directly proportional. Semakin banyak air disesarkan, semakin tinggi daya apungan. So higher buoyant force, higher wave of water displaced. Buoyant force equal wave of water displaced. Semakin besar daya apungan, semakin besar berat air disesarkan, atau daya apungan sama dengan berat air disesarkan. Kadang relationship ni kita boleh bagi dalam bentuk persamaan kalau memang dalam formula pun ada persamaan ni kan. Jadi kita dah belajar Archimedes principle mengatakan buoyant force sama dengan wave of water displaced. Daya apungan sama dengan berat air yang disesarkan. Okey, seterusnya kita pergi ke soalan seterusnya. Namakan prinsip-prinsip yang terlibat. Name the physics principle involved. Of course, Archimedes principle. I missed the answer. So, Archimedes principle. Now, explain. This is a hot air balloon. So, explain why the hot air balloon rise up when the air in the balloon is heated. Okay, so the question, soalan ni nak kita terangkan kenapa balon udara yang panas, yang mengandung udara panas akan naik ke atas. So kita kena terangkan, dan biasanya cara yang paling mudah ialah kita terangkan dari segi daya paduan yang bertindak pada balon udara panas ini. So kita mulakan, kita nak dia ke atas, bermaksud kita nak berat dia lebih ringan daripada. So kita tahu dulu ada dua daya kan. Satu ialah berat ke bawah, satu lagi ialah daya apungan atau buoyant force upward, wave downward, right? So kita nak siapa besar dalam kes ni? Sebab nak naik ke atas, so means daya apungan kena ataupun buoyant force must be greater than the wave of the balloon, right? So first thing, density of air in the balloon is lower. So density of air in the balloon is lower. Okay. Ideally kita nak apa? Wave of balloon is lower, right? So to reduce the mass. So kita ada yang pertama, nak reduce mass, kita lower the density of the air in the balloon itself, so that we have a buoyant force larger than the wave, right? So resultant force outward, therefore daya padu ke atas dan balon udara tu akan naik ke atas. Okey, boleh faham So ini cara yang mudah lah kita relatekan dengan daya paduan dulu. Tengok dulu apa dua daya yang tindak pada balon, dan kita nak tengok siapa nak naik, kalau naik atas siapa kena besar. So daya apungan besar. Macam mana nak daya apungan besar? Density ataupun jisim dia ni kena udara dan juga berat ni kena apa? Kena kecil lah. Gitu. Okey, so kita teruskan dengan soalan solving problem. Okey. So, diagram 9.3 shows the air balloon which is used as a weather balloon to carry a radio sound instrument for collecting data about the atmosphere. The weather balloon rise up when it is released in the morning. Okay. So, balloon kaji cuaca itu naik ke atas apabila ia dilepaskan pada waktu pagi. So, our task is suggest and explain how to produce a weather balloon which is able to carry the radio sound instrument to a higher altitude in a shorter time based on the following aspect. Okay, so ada three aspect here. The gas used in the weather balloon. So gas here used. Remember, we have to have lower density right here. The material used for the balloon and the size of the balloon. Okay, so let's look at the possible answer. So the gas. Okay, should be used helium or hydrogen because low density, light, ketepatan rendah atau ringan. Okay, yang kedua kita cakap pasal sifat balloon tu, gas tu, low density or ketepatan gas rendah, light lah. Kalau low density, partner is light lah or ringan, right? The third one is the characteristic of the material for the balloon itself. So elastic, strong material, kenyal, bahan yang kuat. Okay, reason, withstand pressure, not burst, prevent explosion, lasting, durable. Durable ni kuat lah menahan tekanan, tidak pecah, menahan dari pecah, tahan lama atau kuat. Itu ni possible answer lah yang kita boleh pilih. Dan biasanya kita ambil satu cukup, strong material. Kalau strong, partner dia ada apa? Mana partner dia? Durable or tidak pecah. Strong. Strong means does not break on you, not burst, kan? Okay, next also, other than strong is, we talk about low density, right? So low density material. So it will be light, small mass, ringan. So easy to move up in a shorter time. And it should be waterproof, airproof, waterproof, airproof. Airproof means what we call, the air inside cannot move out easily. Okay. Gas not lost, diffusion, and does not absorb water, especially during rain. Air cannot enter, tidak menyerap air atau udara, elak penyerapan. Okay, next, the material. So we talk about the material. Just now we talk about the characteristic. So the material is nylon, elastic, light, strong, water, so on lah. Okay. Okay, last one is the size. We talk about the size, and the size normally equal to the large volume of air displaced. We have to have large buoyant force, or isi padu udara sesakan besar. Ingat kita belajar isi padu udara sesakan sama dengan isi padu objek kita kan. So kalau nak isi padu udara besar, objek kena besar lah. That's what large volume, large size of balloon. So we have to have, we want to have daya api yang besar. Okay, so that's the end of question 9. Okay. So we move to the next question.